Then we identify the key K with the elbow method, and we pick the fewest number of cluster, that is the cluster size, that reduces the average distance. So we plot the average distance from observations from the cluster centroid to identify which cluster we need to interpret the cluster size. So for every cluster, plot the average distance and label it as number of clusters, y label average distance, and it. So we plot this elbow plot. So now you can see this elbow plot for different cluster size from 1 to 10. So we need to select the value of K, that is the number of cluster, where the average distance reduces. So now if you see 1, its average distance is high. Then here at 2 it reduces, 3 it further reduces. Then after 3, if you see, the average distance isn't drastically reducing. So we interpret as a 3 cluster solution. So 3 clusters will be appropriate for this data. That is what we interpret from this elbow plot. So after we know the value of K, that is cluster size, we specify the cluster size and perform k-means clustering. So we use k-means, pass the argument as number of cluster 3, maximum iteration 300, random state we haven't specified, and then fit the cluster model on the data. Okay, so now if we check the columns of the city group standard STD data frame, now you see we have assigned cluster. So let's see the data. So here so user locations city 0 the cluster assigned is 0. User location city 3, the cluster assigned is 2. So let's check the cluster distribution or cluster size population, so that we can understand that what is the cluster size or what is the population size for each cluster. So that we use value counts and use the plot bar function. So now you see cluster 0, cluster 2, cluster 1 and the samples. So cluster 0 has maximum population, then cluster 2 and then cluster 1. So let's again verify the columns. Now if you see, okay, you have done clustering and group the data into 3 clusters. Now cluster 0 will have cities with similar characteristics. Cluster 2 will have cities that may be grouped based on some similarities. Cluster 1 will have cities that are grouped based on some kind of similarities. But we want to interpret that which cluster and in which cluster what attribute is significant. So this process, one has to do cluster profiling to understand that what is your cluster, what is the characteristics of that cluster, how they were grouped based on what similarity. So this is termed as cluster profiling. We here now each cluster there are different attributes for the data. So now we do a principal component analysis to do dimension reduction and get the sense in 2 dimension so that we can easily interpret, because now you have say yeah 9 attributes. So now from 9 attributes can we do dimension reduction and then make the interpretation simple in 2 components, and that 2 components having the most relevance or the most importance. So we do a PCA. So that is, we use PCA function, number of components to, and fit it on the data, and then we create X, Y and fit transform for the data, and then plot the scatter plot to identify the components for simplicity. So you can see now 3 clusters, one representing black, one cluster representing gray, and another cluster representing white. Actually you cannot see this color white, but there are data points labeled in white color. The Other way you can do variable reduction is also using canonical discriminant analysis. So one is you use PCA, or you can also do a discriminant analysis. So what does this discriminant analysis do is create a smaller number of variables, then linear combination of the clustering variables is taken, and then ordered by the proportion of the variance. So the most of the variance will be for the first few variables. So the first few variables will give you the maximum variance that is accounted. So again we use scikit-learn package and return the first two canonical variables. So we do, so from scikit-learn library we import PCA, and then pass in to return the first two canonical variables, then fit this to the data set, and then plot the first canonical variable on x axis and second on y axis. So let's see. So if you see the plot, the close or overlapping clusters indicate that correlated variables with low in-class variance. So the separation is not that good if you see close or overlapping clusters. So now if you see, there is the cluster shown in white color, the data points, the points in black, and then the gray is very close and overlapping. That is why you can't see. So what this says, that we interpreted a 3 cluster solution, but a 2 cluster might be better or appropriate in such cases. So even in fact for this case we considered to perform, you choose the cluster size as 3, but 2 might be more appropriate. So let's peek into the data to check the columns. So now you see x, y are the 2 variables that signifies the most of the variance. So let's check the data. The next step is, like mentioned earlier, we have to do profiling of the clusters to get in-depth information about that what are the points, who are the customers, what are the profile, what is the cluster all about, what similarity, based on what similarity the clustering is done. So we have to do profiling.